Picture this. It's 11:47 p.m. You are in Chicago. Cold wind, light rain. Your customer is standing by the roadside, shaken, soaked, headlights flickering behind them. They open their phone. One photo, a dented bumper, one sentence. Someone hit me. Now stop and ask. Can your system do anything with that? Can your AI take a photo and a message and turn it into action? Can it extract what's important, check the policy, decide coverage, score risk, and route it? All before the tow truck even shows up? This isn't science fiction. This is what modern claims triage looks like. With multimodal AI, line graph reasoning, and real-world routing logic, watch mine do it, end to end. Up next, the live demo. Let me show you how our claims intake agent works, end to end in under 90 seconds. First, I upload a real photo of the car after a minor accident. I type in a short note, Chicago area, light rain, bumper hit, third party involved. Then just hit submit and the AI takes over. It starts by reading the image and the text, pulling out exactly what matters. What part is damaged? What's the severity? Who was involved? Next, it searches the policy using RAGEsh, retrieval augmented generation. It brings back real policy chunks, coverages and exclusions, so every decision is backed by evidence. Here come the results. Damage, front bumper dent, moderate. Coverage, collision, estimated $500 deductible. Risk score, 62, medium based on incident time and third party involvement. Routing, sent automatically to the body shop queue with an ETA. Click into evidence. You will see exactly which lines from the policy triggered that coverage call. No black box logic. Just traceable, explainable AI. And check this out. Each step is timed. Image analysis, entity extraction, policy retrieval, reasoning, scoring, routing. This is what modern claims automation looks like. Fast, fair, fully auditable. And yes, you can build this with LangGraph, Fast API and a few tools. Stick around. Next up is the architecture and the full code walkthrough. Let me walk you through the architecture behind our claims intake and triage agent, step by step. Everything starts with the user uploading incident details and photos, like a damaged bumper or a short note describing what happened. The agent kicks off by running ingest multimodal, which takes both image and text input. Next, we normalize the entities, extracting the right part names, date, severity, injuries, and more, then move into policy retrieval, powered by RAG, or retrieval augmented generation. From there, the agent runs coverage reasoning, comparing the extracted data to actual policy sections using tools like policy search and policy index. After that, it calculates a risk score and makes a routing decision based on confidence, coverage, and priority. Finally, we assign the claim to the right queue, whether that's F&all, body shop, SIU, or a human adjuster, and a work item gets created instantly using the work.create function. Underneath, we log everything, uploaded files, claim JSON, and the retrieve policy chunks. So every step is traceable and audit ready. This is smart, explainable AI, automating what used to take hours in just seconds. Now, let's talk about the brain of this entire system, our LangGraph workflow. This isn't just a bunch of functions, it's a stateful pipeline, where each step builds on the one before it. Here's how it flows. We go from ingest multimodal to normalized entities, to policy retrieval, then on to coverage reasoner, risk score, route decider, and finally persist. And emit, each node has a clear job, and every decision is traceable. Let's walk through it. It starts with ingest multimodal. Here we take the uploaded image and description and use a vision prompt to detect damage, like what part of the car is hit and how bad it is. At the same time, a text prompt runs NER to pull out structured info, the date and time of the incident, the location, whether a third party was involved, any injuries, and a short summary. The output, clean, strict JSON, no guessing, no fluff. Then comes normalize entities. We clean up part names, standardize the format, and make sure severity is clamped between 1 and 5. That way, everything downstream stays consistent and reliable. Next is policy retrieval. This is where we search the actual policy using RAG, retrieval augmented generation. We bring back only the relevant chunks, coverages, exclusions, terms that apply to the situation. That feeds into coverage reasoner, which makes a call, is this incident covered or not? It also provides a short rationale, highlights the matched coverages, any unmet exclusions, and exactly where that info came from. Then we hit risk towards a scorer. It combines the severity, presence of third parties, injuries, time of day, event coverage uncertainty, and gives us a score from 0 to 100, along with the reasoning behind it. And finally, route decider makes the call. Should this claim go to FANOL, body shop, SIU, or a human adjuster? Each decision includes a clear, explainable rationale. No mystery boxes here. And the best part, every single step is timed and logged. So if you ever need to review, audit, or debug, you know exactly what happened and how long it took. It's fast, explainable, and built for real-world accountability.
To make this agent operational, we expose MCP tools the LLM can call policy, search for RAG, policy, index to add new PDFs, claims, save for storage, work, create to open a ticket in the correct queue with SLA, and audit.log to capture every step. During policy retrieval, the model calls policy search. After route add decider, it opens a work item with priority and SLA, then logs the triage trace. Let's dive into the backend architecture powering our claims intake and triage engine. First up, main.py is the controller. It defines the fast API endpoints that the front end or any client talks to. Key routes include post, API claim, submit. This receives uploaded files and form data, writes them to storage, then kicks off the run triage at workflow to process the claim end to end. Additional support routes, listing claims, fetching individual claims, deleting them, and serving analytics for dashboard visualizations. Then we have config.py, which centralizes all configuration, environment variables like API keys, upload directories, model names, RAG chunk sizes, and queue thresholds. It ensures our code is flexible and zero-drift in production. Under the hood, graph.py defines the line graph pipeline and sets up the sequential nodes. Just multimodal normalized. Entry path, policy, integral coverage, listener, risk, owner, route, header, persist, bit.
Each stage transforms the claim state, and at the end, the workflow returns both the decision and timed audit data to trace performance. MCP tools, PI provides real tools for the LLM to call. Think of this as giving the AI hands. The defined tools include policy search, retrieve relevant policy chunks, drag a policy, index, add new documents to your vector-based claims, save, persist the claim, JSON work.create, open a new work item with SLA and queue assignment audit.log, record each step of the triage pipeline. These integrate seamlessly with the line graph nodes, making the reasoning both interactive and action-driven. Next, the models folder holds your pydantic models defining data structures, claims, extracted entities, risk score, coverage result, and the routing response. This ensures clear, validated structure across inputs and outputs, plus clean, fast API documentation.
Finally, files like utils.py, if present, house helper functions like timers to measure node execution time, file system operations, or any small parsing tasks that keep the main flow clean. Together, this backend is modular, traceable, and built to scale. Fast API for endpoint usability, LangGraph for clear, auditable decision, pipelines, MCP tools to give the AI real capabilities, config and models for operational clarity. That's the backend engine of our claims triage agent. Up next, the front end, where this logic becomes a slick, interactive user experience. Now, let's switch gears and explore the front end, where users interact with the claims intake and triage agent. 1. Landing and upload form. At the core, we have the claim form interface. This React component lets users enter core info, policy number, date, time, location, description, checkboxes for third-party involvement or injuries, and even an optional police report upload. The file uploader handles images and documents like photos of the bumper. When you hit submit, it packages everything into a multi-part request and sends it to the odd API claims, say submit endpoint, triggering the AI processing engine. 2. State and feedback. While the backend is processing, a loading spinner or skeleton view provides immediate feedback. No dead air moments. This ensures users know their input is being handled. Once completed, the interface displays result cards. Damage detected, coverage decision, risk score, routing outcome, each populated dynamically from the API response. It's clean, compartmentalized, and visually intuitive. 3. Evidence drawer. Below the main cards, a collapsible evidence panel reveals the actual policy text chunks that inform the coverage decision. Users can glance at the exact language, transparency in action. 4. Performance timeline. Also in the UI is a timeline of processing steps, like image analysis, entity extraction, policy retrieval, etc., each with timing info. This gives teams insight into performance and rare bottlenecks. 5. API hooks and components under the hood. The front end uses modular, reusable components, uploader form, result cards, evidence drawer, risk tile, timeline, and routing banner. Each component receives clean prop objects, matching the backend's response schema. The API calls are handled via a central service module, keeping HTTP logic decoupled from UI. Error states, validation, and responsiveness are all accounted for, wrapped so the front end delivers polished user experience while staying tightly aligned with the backend's structured responses. Upload, API call, loading state result cards, plus evidence drawer, analytics ready timeline, clean component architecture. That's your sleek front end interface, driving adoption and trust. Up next, full stack integration and deployment tips.
And that's an intake to routing AI you can demo today and scale tomorrow. Want to deploy it? Start with fast API plus lang graph on the backend. Hook in your vector DB for policy chunks and drop the front end into Vercel, Netlify, or your internal cloud stack. Just set your .env, configure your queues, and you're ready to run. If this helped, hit subscribe, give it a like, and drop a comment. Which queue would you automate first? FNOL, Bodyshop, or SIU? Or tell me how you're running it. AWS, Superbase, Pinecone, something else? I'll pin the best ones and reply with tips.